Welcome back to the video series Programming in Python, and this is session 5. In the past 4 sessions, we saw about introduction to Python, flow of control, functions, and strings. In this session, we'll talk about lists, how to use lists, what are the different properties, and how to manipulate elements of the list. And the rest of the topics we will see in upcoming videos. What is a list? List is an ordered sequence of one or more elements, and a list is mutable. When we talked about strings, we mentioned that a string is a list of characters, ordered sequence of characters, and it's immutable. List is an opposite of it, but we'll see the different properties for that. A list can have elements of different data types, including another list itself. Against strings, this is an important property because string can have only characters, whereas a list can have elements of different data types, including another list. It's very useful to group elements of mixed data types within a list. We'll see some examples later. As I mentioned earlier, strings deal with only characters. Elements of a list are enclosed in square brackets and separated by a comma. Between strings, lists, tuples, and dictionaries, the usage or representation varies. We'll have to keep that in mind. In the case of lists, it's square brackets and the elements are separated by a comma. And the indices start from 0. Just like in strings, list elements can be accessed with indices, and the index numbers are as we used in strings. Let's see some simple examples of lists. Example 1, list 1 equal to 2, 4, 5.6, ABC within quotes, and a list itself of 2 elements. So list accepts or accommodates different data types as we saw in the previous slide. When I print it, the printout comes up like this as we gave in the list definition. Second example, this is to access a particular element of a list with the index number. Here I'm accessing the first element with the index 0. List 1 of 0 is 2. Similarly, if I give 1, 2, and 3, the appropriate list element will be printed out. For example, list 1 of -1. As we saw in string, the negative numbers are going to give us element values from the right to the left. So if I'm giving -1, it's going to show me the last element on the right side, which is a list in this particular example. Mutability. Mutability is a property where the elements of a list can be changed. So this is one example. I have a list of car makers and I'm printing the list as is. This is what I'm getting. And then one of the elements, I'm changing one of the elements, say element 2, that is index 1, to a different car maker. Here in this case, I'm changing the Honda to Nissan and I print it. This is what I'm getting. List operations. As in the case of strings, we have 4 different operations for lists also. Same 4 as in strings. Concatenation, joining 2 or more lists with a plus operator. Repetition, repeating a list multiple times with the star operator. Membership, in or not in. Check if a particular element is part of a list, return true. Check if a particular element is not part of the list, then return true. So that's the membership operations. And then slicing gets one or more elements of a list with a given range of index values. And we have the same range conditions. List of A to B will fetch elements of index A through B minus 1. We have to remember when we look for specific elements to be fetched. Some examples for list operations. Concatenation. I have 2 lists, one with a particular string, another with another string. And if I print or if I add those 2 lists with simple plus operator, this is what I'm going to get. If I'm going to add one more, same. You can keep adding to that. Next is repetition with a star operator. I have list 1 into 3. I'm using the same list that I created earlier, but multiplying by 3 to repeat it 3 times. This is what I'm going to get. I can use the plus operator along with my multiplication operator, repetition operator as well. Here is an example. Multiply list 1 3 times and multiply list 2 3 times and get me the output. So I'm going to get the elements of list 1 3 times first, and then list 2 3 times. That's the order I have here. So that's how I'm going to get the output. An example for membership, I have a list with 4 different car makers, and I'm going to check if Ford is part of the list. Ford in list. Ford is present in the list, so it's going to say true. And Nissan in list 1. I'm going to check if Nissan as a car maker is present. Since Nissan is not there in the list I have created, it's going to show me false. Similarly, for not in operator, Maruti not in list 1. There is no Maruti, so it's going to show true. And Tata not in. It's going to check if Tata is not present, but since Tata is present here, it's going to show me false. And an example for slicing. I have 4 different elements in this list 1, and I want to look at, or I want to fetch elements of index 1 through 4. Remember A to B, where I'm going to get elements of index A to B minus 1, which is 1 to 3. So 1, 2, and 3. Next is an example for a range with a step value, starting with index 0, going up to index 10, though there is not that many elements. And any time it goes beyond the fourth element, it's going to ignore the number. And I'm going to step up by 2. So index 0 is Honda, stepping up by 2. Index 1, 2 is Tata. So I'm going to get these values. Traversing lists, just like in strings, how do we traverse through as a particular list? The same loops, for loop and while loops. Example for for loop, I have a list, 4 elements. For each element in list 1, print the element. So I'm going to get Honda, Toyota, Tata, and Ford, each of this element printed. Similar in the while loop, as long as there is an element present in the list, print me the element value. List methods and built-in functions. Just like in strings, we have a lot of Python provided built-in functions. For the full list, please refer to this link. This is from the Python organization. But here is a sample list of built-in functions, list built-in functions. Append, add list elements, extend, stretch the list, count of elements, insert an element in a particular position, index value of an element, remove an element from the list, sort both ascending and descending, or forward and reverse the elements in the list, minimum, maximum, sum, and pop, just remove. Nested list. When a list becomes an element of another list, it's called a nested list. Remember when we saw the properties of list earlier, a list can also be part of a list elements. So that particular list can be called or will be called a nested list. To access the element of a nested list, 2 indices are needed. I have to have one index for accessing the list itself as an element in the parent list, and then element of the child list. For example, I have a list here, Honda, Toyota, and a list within that list is Kia, GMC, and Fiat, and the parent elements Tata and Ford. So if you want access one of these elements Kia, GMC, and Fiat, I need to refer that I need to access that with the index number for this whole list first and the element within that list. Here is how it is. If I print just with one element of, say, list 1 of 0, I'm going to get the first element of the parent list. 2, I'm going to get the entire list. This particular index, single value index, refers to the whole list as part of the parent list. And when I give 2 indices, and remember the syntax, it cannot be colon or comma or whatever, you have to have 2 index values within individual parentheses in these square brackets. So 2 comma 2, which is the second element or second index of first parent list. So I'm going to get Fiat. Next, we'll see how copying lists work. This can be done in 4 different ways. One is copy by assigning a list to a new list. Both refer to the same list. So the object IDs of both lists will be same. So any change to one list will reflect in the other list. Here is an example. I have a list of even numbers from 2 to 10, and I'm assigning list 1 to list 2 as a new list. I'm not giving values to the list 2 directly. I'm assigning list 1 to list 2. And if I print list 1 and list 2, I'm going to get the value of the elements of list 1 and elements of list 2 are same. And if you print the IDs, the ID will be single one, both of them. Just to visualize the list being same, when we assign one list to another, the values or elements being same. Here is an example. I'm appending 12 to list 2. Since they referred both lists refer to one particular object ID, if I print list 1 and list 2, we can see that the add element 12 has been added to both lists. So when there is an assignment of lists from one list to another without adding values or making any changes to the values, any change to one list will reflect in another. It doesn't have to be first or second. Any change to any list will reflect in the other one. The next possible way of copying list is slicing. Slicing the original list and store it in a new variable. For example, I have the same list. I'm slicing that list and assigning that resultant value to the second list. This particular operation means assign all values or slice this particular list with all values and assign to list 2. If I print list 1 and list 2, I'm going to get same values basically, because I did not choose any particular element or remove any particular element. I'm reading all elements and assigning it to the list 2. However, the moment I do an operation on those values or elements of list 1, the ID is different. The list 2 is a new object altogether. It's not the same as list 1. Just to show that I'm adding one element to one of these lists. Say list 2, I'm adding 12. If I print list 1 and list 2, you can see that the 12 has been added to list 2 alone and not list 1. So when I assign one list completely to the another list, there is no change. They are referred to, or they are representing same object. Whereas when I do an operation and assign that to a different list variable, they are two different lists and they are not related to each other anyway, and they can be operated upon individually. Next option is to use the built-in function list. I have the same example of list 1 equal to 4, 6, 8, 10, and I am sending list 2 with the built-in function of list of list 1. If I print list 1 and list 2, essentially they will be same. So if I append an element to one of this list or list 2, they are going to show me the same values. The fourth one is using a copy function of copy module. For this to happen, I have remember we have to if you have to use a function within a module, we have to import the module first. So I'm going to import the module copy with the import function into our working domain, and then I have same list 1 equal to 2, 4, 6, 8, 10, list 2 equal to module dot function and the list copy dot copy is the module here and the copy function of list 1, assign that to list 2, print this, and append value 12 to list 2. Since the copy function will have operations on this particular list, I'm going to have the list 2 alone getting appended with the new value of element 12. List as an argument to a function. A list can be passed as argument to a function. When a list is passed as an argument, only a reference is passed. So any change within the list inside the function reflects in the actual list in the calling function. Any operation like adding an element or changing an element or removing an element. So any operation within the list will reflect in the calling function when the return is happening. Whereas if the list is assigned with a new value altogether, if I'm making an assignment to the list, same list, which was passed as an argument, but if I'm assigning a new value altogether, this change will not reflect in the return value. A new list object is getting created and becomes a local copy of that function. Whenever there is a local copy, whenever the list becomes local copy, it does not reflect in the calling function. The scope or life of that particular local copy ends within the function itself. Let's see some sample programs for both cases, where the changes within the list reflecting in the calling function and a value being assigned to a list not reflecting in the calling function. We'll start with a simple example. I'm going to define a function print list of lst1 or item in lst1 print. I have to define the list now. List 1 equal to some numbers, and I'm calling the function prnt underscore list of list. I'm calling the same function and it's printing all the values. Just to see reusability under different list name, I'm going to have lst2, a new list being defined, a new set of numbers, and I'm going to call of lst2. I'm getting the values of our elements getting printed with a new function call. We'll see another example with the same list or similar list, but user entering the values for the elements. Let me open the file. I have stored it as a Python file because the programs are getting larger and larger. It's difficult to keep typing and showing at the same time while explaining. So here is a sample where the user is I'm defining the function, same function, a print list, and reading the list, print the items or elements in that list. But instead of defining or hard coding the elements of the list, I'm going to ask the user to enter those list elements and print them. So I'm having two function calls. One is getting the list and the next is printing the list. Let's run and see what happens. So how many items do you want in the list? So let's say I want 5. Enter 1, 2, 3, 4, 5. Print those values. So instead of hard coding, making that list elements to be fixed, giving a user an option to enter the list is a better way of dealing with certain lists. Here it's a very simple and just numbers, but when we are dealing with complex programming, a list need not be coming from within. It has to be dealt in. Ideally, it has to be dealt by the programmer. It has to be read from somewhere or created within the program. So it's best to leave it to the user to deal with the list. Next, we'll take a sample to see when there is a change within the list, an element getting changed or multiple elements getting changed within the list, getting reflected in the parent function or calling function. Let me open that. So here I'm having a function for incrementing an element value for range 0 to length of the list. Add 10 to each of this element. Increment it, increment the I value, that is the element index, and add 10 to each of the element value. So what I'm trying to show here is the object id being same, though there are two different lists. When there is a change within, I'm going to change within the elements of a list, the changes are reflecting in the function. That's what we are going to see. So I'm going to show the object id being same even if there is a change in values. So print the object id inside the function in the first place, reference id of list in main, and then list before and after the function calls. So let's see how it goes. So I'm defining a list of 10, 20, 30, 40, and 50 here. And with the increment, the output list will be 20, 30, 40, 50, and 60 because these changes will reflect in the main function or calling function and the IDs of both lists being same. So you look at this. Reference of list in main. This is the object ID, which is the main one. The list before the function call. This is the original list we gave in the program. And the object ID within the function. When there is a change happening, what is the object ID? And the list after the function call. See the value being changed. This change is happening within the function. But since the operation is on the elements of the list and we are not assigning new value to the list itself, these changes are reflecting in the calling function. Next, we'll see an example for a change or a new value assignment to the list within the function, creating a local copy and not being reflected on the calling function. See here, I mean, it's almost a replica of the previous program, except that I'm assigning new set of elements to the list that is being used as an argument. Instead of just reading the past list and incrementing the value by 10, I'm having a completely new set of elements being assigned to the list argument within the function. So let's see what happens. See here, the reference IDs before calling the main function and inside the function is this. But after reassignment, look at the ID, it's getting changed here. Meaning, this is a local copy and there is no reference or there is no relationship with this to the calling function. The calling function uh, is completely independent. So I have the original values here, and after the function call, my values remaining the same. Meaning, whatever I did within the function did not reflect on the calling function. Next, we'll see a sample program for list manipulation, how to add elements to the list, change, remove, sort, and so on. Let me open the sample program. Here's a sample program driven by user choice. There is a list that is given in the beginning and a variable called action with an initial value set as 0. And the conditions are while the option is true, option 1 to 10, each having its own action. Append an element, insert an element at the desired position, append a list itself to the given list, modify an existing element, deleting an existing element by its position and then value, sort ascending and descending, simple display of the list, and then exit. So the coding goes like this. Choice 1, enter the element to append. You have a list given already, and the first choice is element to append. Once the user enters the element, append that. And similarly, insert, a change in element, and so on. So let's run this and see how it goes. These are all the manipulations. I mean, you have a list, and how do I keep changing the list for my intention or for my objective? So once I run, I get these options, and my original list displayed here. So I'm going with option 1 to append an element. So let's say I add 6. I add one more, that's 7. I have 6 and 7 added. I'm going to insert an element somewhere inside. So I'm giving an option of 2, and it's going to ask me what element to insert. I'm saying say 9, and it's going to ask me the position where I want to insert. Let me say 2. 2 will be element number 3. So 1 to 9, and it's getting inserted at the as third element. And insert a list itself or append a list itself. So it's asking me what is the number of elements in the list. Let me say 4. So it's going to ask me expect 4 elements from me. So I'm going to give 4 values now. So it says list is extended, and I'm seeing that list as an element. The entire list 9987 as a list within the original list. So we can actually deal with lists within the list. Here it's just an append. We should be able to, by right programming, we should be able to insert or even find out or identify a list within the list and then delete its elements or the entire list itself. It's possible. Modify an existing element. I'm going to give option 4. It's going to ask me what element I want to modify. Let me say 2. It wants the new element value. I'm going to say 3. So I should see 1, 2, 3, 3. Yes. And delete an element by its position. Say 4. So and so on. So we have we can define manipulations in many ways we want. So this is just a sample of it. So I say enter 10 and come out. Just a preview of the programming. Once again, multiple choices. Choice 1, 2, 3. Here we have the manipulation to append and insert in a particular position with position in element. And the third option is to enter a list itself or append a list itself. So I'm creating a list here with user entry. And here is the list getting finalized. And then I'm adding that entire list to the parent list with append command. And here I'm asking for the user to give the position and the new element. So I'm going to replace that. Here I'm not using the replace operation, rather I'm assigning the value to the list position or element position with an index. We should be able to use replace also as a operation directly, or replace function directly, built-in function. And deletion operations, remove, sort, and so on. Let's quickly recap of this whole session. List is a sequence of elements enclosed within square brackets, and the elements are separated by a comma. Indexing is used to access elements. First element has an index of 0. Negative indexing is also possible, like in strings. Python lists are mutable. As we saw earlier, the values of a list can be changed. Concatenation, repetition, membership, and slicing are some list operations. Each element of a list can be accessed with a for or while loop, just like in strings. There are many built-in functions for list operations in Python. List within a list is called a nested list. Here are some sample programs that you can try hands-on. Write a program to find the largest element of a list. Remember, the type of data, the data types of these elements should be same. Otherwise, it's very difficult to find the largest element. If there are mismatches, it's not going to sort properly or it will throw an error. Write a program to find a number of times an element appears in the list. Basically, find the number of repetitions of a given element which can be received from the user. Write a program to compare two lists and print the elements that are present in both. Receive the two lists from the user and compare those lists to see how many elements or what elements are present in both lists and print those elements alone. Write a program to delete duplicate elements from a list. Just a hint, this can be extension of the program too, where we find the number of elements being repeated, a number of times a particular element appears on a list. And then write a program to receive a list from the user, reverse the element and print the elements. Of course, try out a few by yourself and see how things turn out. There are multiple ways we can manipulate list elements, list within a list, adding list, removing a list, elements, accessing elements of a list within a list, and so on. There are so many we saw as an explanation, but trying hands-on will help you recall and utilize where necessary. See you in the next session. Until then, goodbye.